Beginning with zooming out quite a bit. 50 years ago, the architect, the inventor, the futurist Buckminster Fuller gave a speech to the American Association of Planners, where he argued that we have to realize that we do not anymore live on planet Earth. We live on spaceship Earth. And his argument was simply that humans have influenced the biosphere, the Earth, to such an extent that we now also have to take responsibility for this Earth and manage it and take care of it in all kinds of ways. He also argued that, and that conclusion, I think 50 years on, is rather obvious that if that wasn't news at the time, today that is the reality we live in. He also talked about developing an operational manual for spaceship Earth. And that was maybe also 50 years on a bit naive. How do we develop such an operational manual? And being spoken in an era where we have great confidence in new technology and engineering and how to develop things and take care of these. That is maybe another thing that we realize that this is maybe more complicated than we may have thought. Still, the challenge is there. And today we live every day in the awareness of how vulnerable this Earth is. One way of describing it has been with the concept of 9 planetary limits that I'm sure most of you have heard of, that there are possible to identify at least 9 limits that we cannot exceed if we are to survive on Earth and keeping the biosphere alive. And important to emphasize is that it's not necessarily the ones that we most often talk about, like CO2 emissions and so forth, that are most critical. There are others there that are even more critical. And other major drivers today are, of course, the urbanization of the globe. And we see all these numbers mentioned every day, that we build 2 Vancouvers a week, or that we, in a decade's time, will not be half of the world's population will be living in cities, but maybe 2/3, that we are building in the next decades an urban land to the extent of all of France, and all of Germany, and all of Spain. These tremendous extensions of our cities. In summary, this makes all these changes on the globe becoming urban issues, that it's the future of the cities on the Earth that are in focus for all these challenges we are facing. But it also means that how we build our cities may be the solution to this. So it's a tremendous challenge coming into the laps of the people sitting in this room. It's us, actually, in a way that has never been in focus in that manner before, that a lot of people around the Earth, scientists, politicians, and so on, look to see the answers. What will be the possible developments of our cities? Because in how we build the future, our future cities will also influence the societies and the way we live on the planet. And that may also be part of the solution. So it's tremendous knowledge challenges I think we're facing, all of us in this room today, both from practice and science, and how to deal with that. And I think that's also a reason when we maybe should take a short while and think about what is it actually that we deal with? What is it that we work with as researchers and practitioners here working with cities and the development of cities? I think at times it becomes very simplified, like when we talk about the extreme housing shortage in Sweden, for instance. And we just set up a number of 700,000 new housing units to be built within a certain period, without really thinking about what is it that we're building. What is the product in this sense? It seems like it's any kind of, it's like it would be cars or soap, it's just to raise the production. But this concerns so much more. And one of the issues that I think we all share is the problem of saying, well, 700 housing units, fine, we can decide that, but what kind of cities are we going to build with these 700 houses? And there's much less talk about that. So, what we talk about here, I think, is something extremely fundamental to humans. Humans, like so many other animals, always and have always changed their environment in different ways. It's not possible to exist as a human without an environment, obviously. And it seems like it's not possible to exist as a human without changing that environment, accommodating it for our purposes and uses. So this is not something that is kind of late in the history of humanity. We have always changed and developed and designed the environment in different ways. And by doing that, we've been able to overcome certain fundamental limits. It's obvious that we overcome things in space by building bridges across rivers or roads between different places that facilitate the movement between places. But it's also, I think it's very important to emphasize that we also overcome time, because we build and change the environment using a material that is very slow in changing and very permanent. So if we build something today, it will be there tomorrow, and the next year, and the next year, and so on. Like here in Gothenburg, we will live in parts that are 400 years old and still use that. So it's a very fundamental material that we deal with, and I think it's important to remember that when we now feel these pressures of developing a lot of new housing, but also when thinking about how to develop cities so that they will fit the future in a more sustainable way. So by doing this and using this very slow and permanent material, built form and so forth, we are able to structure a lot of the important and essential processes in society. But we talk a lot about these different social, economic, ecological and technical processes like social segregation or the future economy, increasingly about ecology, and not least in a place like this at Chalmers of technological systems and so forth. But in the end, all of these are structured and shaped by built form. All these processes have to move through a certain pattern of space formed by this rather low-tech material of built form. So in that sense, we sit on a very powerful medium to shape and structure these developments. But at the same time, we may wonder, how much do we know about this? Are we able to describe these spatial patterns in a powerful way that will make us understand what we're doing and what the effects of what we're doing are? As a matter of fact, we don't even have strong concepts of the difference of these three. How would we describe that from that? Even though we invest huge resources in this, that it stays there for a very long time, and that it structures all of these other important processes. We may say that this is a grid. Well, but there are many, many, many different kinds of grids, and how do we separate that? There's some need, we think, obviously, that to develop new knowledge on how to describe and understand these shapes and patterns. So, to summarize, I think that the essential issue in our research, and a lot of the colleagues that we have invited here today, is the relation between spatial form and human behavior, and try to understand how this actually takes place. And to do that powerfully, and not least to support urban planning and design, we need something that we, in a broad term, here have called spatial morphology. And it's important to emphasize that because we have, here at Chalmers when we started, had the aim to try to grasp a broad set of different ideas, not everything in this field, it's a huge area of research, but to set a rather wide limit to what we do and give it a rather generous term that we call spatial morphology here, and of course a lot of other people call it that too. Anyway, if you start up such an endeavor, not saying that we started from the beginning, but just to explain the thinking in this endeavor, always in research, you have to make representations or descriptions of the thing that you want to study and learn and take, generate new knowledge about. It may seem like we study the world directly, like we, somehow are able to find out things by just observing things. But always you will realize that in research, what researchers deal with is in the representations of the world that simplifies and lifts out what's essential in that area. So in our case, and then of course you can use very different kinds of representation. You can use mathematics, you can use natural language, like Greek in this case, but of course of central interest to us is geometric languages. And it's also important to remember that maybe in the area of research, these areas have been developed very far, while I think there's a lot to do in the area of geometric representations. Anyway, there are many takes on this, and there's been work going on for a long time, and also using different kinds of geometric representations to understand cities and the spatial form of cities. We have something we could call, we're trying to divide things, to sort things a little bit here just to position ourselves, something we could call the Spatial Analysis Group, that goes way back to a person in economics called von Thünen, who looked into how land uses were structured by the distance to the center of a city or a village, depending on the cost of travel and so forth. And this is something that he developed already in 1826, but still is fundamental to urban economics to this day. People like Paul Krugman, who was given the Nobel Prize in economics, refer with emphasis back to that. We have others like Kristaller, who identified how cities and villages in the south of Germany had a rather clear structure and were hierarchical, that surrounded by one larger city, there were found smaller cities. And then and from that he developed the idea that you could also plan this. And this was also very fundamental for the development of neighborhood units and so forth in Sweden and in the Netherlands, for instance. We have other schools, but you see very abstract representations. We have other schools that, thank you, Meta. I couldn't figure that out myself. That we can call the Urban Morphology School, which actually have different directions. So there's sub-schools, the British, the Italian, the French, and so forth. There's a lot of studies going on there, which is much more in detail and has a very different approach scientifically. While the Spatial Analysis School is rather natural science based, this has much more, it's much more based in humanities, historic studies, and so forth. But it has also very different type of representations working with, which is much more closer to architecture, you would say. Of absolutely special interest to us and importance to us is, of course, the Space Syntax School, which we will talk more about. But here I just will look a little bit at the representations, because I think one of the powerful things of space syntax is the concern one took from the very beginning exactly of representations and descriptions of space, where one extremely influential finding of phenomenon here was what has been called the axial maps. I will return to that. Of course, we feel very close to this, and we are also happy to say that to some degree we have also made some additions to this field of research earlier, and we were happy and grateful for that. But we'll come back more to that. Another side that we're also very important for us here at Chalmers is something we could call the Analytical Morphology School, which also has a very mathematical approach, not afraid of quantifying architecture, which can be problematic in some circles. Looking very much in on both buildings and cities and trying to understand basic geometric relationships in these that set boundaries for what actually is possible to generate as architecture or as cities. And here we know that, or here Meta not least, have made very important additions to that field that have also brought great attention to some leading names in that area. So these two last ones are maybe the ones that we build mostly on here at Chalmers. So our idea is, of course, that sometime there could be something like a Chalmers school here, and we will present a little bit of these developments. And when I say the Chalmers school, I should say maybe the KTH Chalmers school, and there's beginnings at TU Delft too, but at the moment and today we choose to call it the Chalmers school. But we will have a lot of time to talk more about this. I think there is another fundamental point to make, and that is that we say we will present our models of the cities and so forth. And when you start to talk about modeling, you enter another huge area and all kinds of possibilities of doing models. Generally, when you speak about models, they are mathematically generated models, and they often concern the development and growth of cities comprising everything. I mean, both buildings and economic activity and growth in population and things like that. All of that is kind of put into a mathematical formula, and you can generate ideas and simulate development of cities and so forth, trying to understand what would be a likely development or understanding the processes in urban growth and so forth. I think the approach that we adhere to is different in that we very much base ourselves on ideas developed in space syntax, and the idea of actually making a difference between, on the one hand, the physical city, the actual built city, and what we could call the lived city and all the kind of urban processes taking place. So the models we talk about are, in that sense, almost like traditional architecture models. They're physical models of the physical structure, even though we use digital tools to represent them. So they differ very much from what often is talked about as models. But even though we say that we model the physical city, or the architecture of the city, if you like, we can look a little bit closer on that. And here I think also there's been very important work done in space syntax, trying to understand more precisely what is it that we model when we say that we model the physical city. And here is a very exciting theory from psychology called the theory of affordances, developed by a person called James Gibson, that I find very exciting. I'm not saying that this is maybe even agreed upon, that this is the center of not even space syntax and modeling. There may be discussions on that. But I think it's a very powerful way of understanding what one is modeling here and what is different here in modeling than from other kinds. Affordances actually is not the physical environment. Affordances is something the physical environment creates potentials for humans to use the physical environment. So affordances is what the physical environment affords a human, for instance. So the affordances is neither the physical environment or human behavior or actions. It's what emerges in the meeting between the two. So you realize this shape creates certain affordances to human, this shape creates other affordances. And furthermore, that makes it clear that if you are not a human, if you are, for instance, a dog, the environment will not afford the same thing to you. Or if you're elderly, or if you're a child, or if you're disabled or something, the environment affords things differently. And also, that makes us look at the built environment in a different way, maybe. That it's not obvious where the chair is. Chair is something that emerges in the meeting between a particular person and a physical environment. And different uses can therefore be discovered in the environment and so forth. Gibson also talks about how we navigate in the environment. He's very concerned about this idea of movement. He has an idea about human navigation in the environment, that is called the theory of reversible occlusion, and let's not get into details about that, but in general he opposes the idea that we're driven by signals, that we see exciting things and then we move in that direction and then we see something else. He says that what we rather do is by moving through the environment, we start to scan and understand how it hangs together. And he illustrates that with a particular image from his book of what happens when you move down a lane, a backyard or a lane, and how certain things are suddenly revealed to you when you move. And over time you start to learn how things hang together. I think there's a very exciting connection to the axial map that is used as so fundamental to space index research. Actually, it's also a set of lines of sight, you could say, that covers the whole accessible space of a particular urban area. So it is, in that sense, exactly what Gibson is talking about, but it covers the whole area, all lines of possible sights. And it adds to that not only lines of sight, and that did, and Gibson didn't stick to that either, it's also about accessibility. So in the end, it's about lines, very simple geometric things, but they represent the ability of the human to see things and also access it by moving. So it combines these very fundamental things of being human in this very simple geometric representation. And that is also something we could talk about as an affordance of fundamental ones. The affordance of visibility and the affordance of accessibility. So that is what we see when we look at the axial line. At least that's an interpretation of what we can see here. And that means that when we scale up this to very large representation of cities like Gothenburg and London here, you start to see what this actually is representing. It's not a physical environment. It's not flows of cars or something. It's actually the affordances allowed by the physical environment for a human moving and seeing. So that's a rather extraordinary thing. And that is the model that is fundamental to a lot of what we do here. In that sense, starting to round this up, I think it's also interesting to look at this from the point of technology. And this is addressing people from Chalmers, from other departments. I don't think there's so many here maybe, but still. This could be seen as a technology. The material we're talking about, the spatial form, but it's of a very different kind. And if you talk to engineers even, or researchers at Chalmers, it's actually very difficult to find a definition on what is technology. I mean, we have this whole campus and everybody, what is it really? And the best definition I have found is by Brian Arthur, American scientist. He says that technology captures phenomena for a purpose. And I think it's quite extraordinary, not least this, capture phenomena, because this is what makes technology work. That is capturing a ray of sun to enhance it through some kind of device for a particular purpose. So there's always something, a driver in every technology that is made use of and directed for a particular purpose. But then we could ask, what is this phenomena in spatial form? In regular technology, it's quite clear that we talk about natural phenomena, like wind or fire or, I don't know, electrons in materials and so forth. But what is the phenomenon in spatial form? Well, actually, it's ourself that is the phenomenon, that is captured for a purpose. It's ourself that is the driver that make the environment work. And of course, then it's a technology of a different kind. It's not a technology of a precise kind that we have a very particular purpose. But we have an environment that helps us navigate through space, for instance, in a certain way. And how we develop that technology, the spatial form, will lead to whether it works, how well it works. Anyway, I should wrap up. And I will do that by saying that over these 3 years, we built this infrastructure, and we're looking forward now to the next step and so forth. But there is also some products that we are developing that we think could be very important for the development of spatial morphology and research in these areas. And it's primarily two books that we've been working very hard on. On the one hand, something we call a theory of spatial form, called Spatial Capital, about measures and meanings in this area. What do I do now? Okay. And the other one is a methodology in spatial morphology. And that is very concerned with what we've been presenting here today. It's very much what we've been doing over the last 3 years and so forth. So this is something that we are working towards. Now I don't know what's happening. But again, emphasizing that what we present today is the infrastructure for further research, I think of a very unusual kind, where we have built models of 5 different cities, 3 Swedish, Stockholm, Gothenburg and Eskilstuna, and 2 European, Amsterdam and London. And we have a lot of different layers that Gianna will talk about later on, different components to these, but they concern the street network, it concerns the buildings, and it concerns the plot systems. And by these we can do all kinds of different analysis of the spatial form of these cities. And most importantly maybe that we can do comparisons between cities, because they're all built in the same manner. But perhaps in the end, the most important thing is that we hope to develop this also in collaboration between the universities, and that we have an infrastructure possible to use by all of the universities for applications, for PhD students, for master students, and so forth. This is one product from this has also been a GIS-based tool called the Play Syntax tool that has been around for a while, but now we have an updated version possible to download on our website as well as at KTA's website that can navigate and use these models and also other models of the same kind. It's also very interesting to know that it's also being used by several the consultancies here in Gothenburg and other parts of Sweden.